In the endless ballet of celestial giants, one tiny world races closest to the sun, scarred by ancient impacts, scorched by solar radiation. This is Mercury. The planet Mercury is named after the messenger of the Roman gods, because even the ancients could see how swift and fleeting it is in the sky. But it wasn't until recently that scientists began unraveling Mercury's many mysteries. Mercury is the smallest planet in our solar system. Its diameter currently measures just over 3,000 miles, about the size of the continental United States. Like Earth, Mercury is a terrestrial planet with three main layers: a core, a mantle, and a crust. Only Mercury's crust has no tectonic plates. Also, its iron core is enormous by comparison, making up 85% of its radius, while Earth's inner and outer core account for just 55%. Because of the core's exceptional size, it's had a surprising influence on Mercury's overall size by causing it to shrink. The hot iron core has slowly cooled and contracted over the planet's 4.5 billion years. In doing so, it pulled Mercury's surface inward and has caused the planet to shrink radially by more than 4 miles. This shrinking planet is also the planet closest to the Sun, orbiting our solar system star at an average distance of roughly 36 million miles. Such proximity affects Mercury's atmosphere, or rather, the lack of one. It only has a very thin exosphere, which is traditionally the outermost layer of a planet's atmosphere. This exosphere is made of oxygen, sodium, hydrogen, helium, and potassium, all whipped up from the planet's surface by solar winds. The lack of atmosphere and close proximity to the Sun also makes Mercury a planet of extremes. The surface temperature can climb to 800 degrees Fahrenheit during the daytime and fall to 290 degrees below zero at night. Mercury's proximity to the Sun is also the reason behind its age-old reputation of being swift and fleeting. The Sun's gravity pulls harder on Mercury than any other planet, and like all planets, Mercury travels in an elliptical orbit, slowing down when it's farther away from the Sun and accelerating as it draws closer. Clocking in at an average speed of over 100,000 miles per hour, Mercury slings around the Sun in just 88 days. From Earth, Mercury is difficult to observe because it's fleeting and so close to the Sun. And so far, it's only been visited by 2 spacecraft, NASA's Mariner 10 and Messenger. Those missions gave us much of what we know today, but future ventures are in the works, with high hopes of revealing more of Mercury's secrets. After Mariner, 10, and Messenger, Mercury's story is still unfolding. The latest mission, BepiColombo, a collaboration between ESA and JAXA, is now en route. Launched in 2018, it's expected to enter orbit around Mercury in 2025. What makes it unique is that it carries 2 orbiters, one to study the planet itself, and another to explore its magnetic field and environment. BepiColombo is using multiple gravity-assist flybys of Earth, Venus, and Mercury to slowly spiral inward. Each pass reveals more glimpses of Mercury's surface, hinting at new surprises yet to be revealed. These flybys have already delivered stunning close-up images of the surface and helped fine-tune the spacecraft's trajectory. What sets BepiColombo apart is its dual orbiter design. The Mercury Planetary Orbiter, MPO, will map the surface and internal structure, while the Mercury Magnetospheric Orbiter, MMO, will study the planet's magnetic field and space environment. After years of anticipation, we are now on the brink of a new era in Mercury science, one that promises to uncover secrets even Messenger couldn't reach. Now that we've explored the basics, let's take a closer look literally, at Mercury's incredible surface. Unlike Earth, its surface has barely changed in billions of years, preserving a history of intense bombardment. Mercury's surface is littered with craters, basins, and long cliff-like features called lobat scarps, which stretch for hundreds of kilometers. These massive wrinkles are the scars of a shrinking planet, a process still ongoing today. Some regions show signs of volcanic plains, suggesting that Mercury was geologically active far longer than we thought. Its oldest impact basin, the Caloris Basin, is over 950 miles across and is surrounded by rings of mountains created by the force of the collision. Did you know that Mercury quakes? Instruments aboard Messenger recorded surface changes that may be signs of Mercury quakes, seismic events caused by the planet's cooling and shrinking core. These quakes aren't like Earth's. They're slow, gradual changes in the crust position, stretching and breaking as the planet contracts. And with its enormous iron core still cooling, Mercury is literally cracking from the inside out. Mercury's formation remains one of the most intriguing puzzles in planetary science. While it shares some characteristics with Earth and Venus, its unusually large iron core and the thin silicate mantle defy expectations from standard models of planet formation. So, how did this peculiar planet come to be? One prominent theory suggests that Mercury was once much larger, possibly similar in size to Earth, but suffered a catastrophic collision early in the solar system's history. In this scenario, a massive impact stripped away much of Mercury's original crust and mantle, leaving behind the dense metallic core we see today. This hit-and-run hypothesis could explain why Mercury's density is so high compared to other terrestrial planets. Another compelling theory proposes that Mercury may have formed from a different set of materials than Earth, Venus, or Mars, closer to the Sun, where lighter elements would have been vaporized and lost to space. In this view, Mercury's composition isn't the result of destruction, but of its proximity to the Sun during its formation. That would mean it's not a broken planet, but a survivor of extreme solar conditions, one that formed differently from the start. There's also a more speculative but fascinating idea, the double planet hypothesis. Some researchers suggest that Mercury may have originally been a part of a binary planetary system, a pair of similarly sized planetary bodies orbiting each other closely. Over time, gravitational interactions or solar tidal forces could have disrupted this delicate balance, either ejecting one partner from the system or causing the two to collide and merge into the Mercury we know today. While there's limited direct evidence for this scenario, it fits within the larger narrative of chaos and collisions that shaped our early solar system. Supporting all these theories is data gathered from missions like Messenger, which revealed unusual abundances of volatile elements on Mercury's surface, like sulfur and potassium. These are not typically expected on a planet that's endured extreme solar radiation. Their presence suggests that Mercury's formation was not only violent, but also chemically complex, requiring a major rethink of the conditions near the early Sun. Future concepts under review at NASA and ESA. Imagine robotic landers that could explore Mercury's surface up close, analyzing rock samples and possibly even drilling into the crust. Such missions would need to endure blistering surface temperatures during the day and freezing lows at night, a technological challenge yet to be solved. There's also growing interest in studying Mercury as a model for exoplanets, especially the rocky, close-in planets found orbiting other stars. As it turns out, Mercury might be the best analog we have for understanding these distant worlds, which are often scorched by their stars and lack atmospheres. In the far future, AI-guided exploration, swarm satellites, or even sample return missions could be possible. Mercury may never host human life, but its role in helping us understand planetary formation, space weathering, and magnetic dynamics is only becoming more important. In a way, Mercury isn't just a target. It's a key to the bigger puzzle of how planetary systems form and evolve. And that wraps up our journey to the smallest, swiftest, and most mysterious planet in our solar system, Mercury. If you enjoyed exploring the extremes of this scorched and shadowed world, imagine what wonders await as we voyage deeper into the cosmos. Thanks for watching, and don't forget to like, subscribe, and hit the notification bell so you don't miss the next stop in our galactic adventure. This is Milky Way Mavericks, unlocking the universe, one world at a time. Until next time, stay curious, space traveler.